Hello everyone, welcome to the sixth lab of ALD. In this lab, I will be explaining the UCB code and then verify the functionality on the quick emulator as well as on the hardware. Let us run through the code once. So this is our UCB algorithm that I have implemented for 8 arms. So you can see that the probabilities for each of the arms has been defined. So you can define it in your way you want. So basically the algorithm is from the main function, the info is sent to the index underscore q function. So this info we are sending to the index underscore q underscore golden, since I have done it on the PS. So I have named it like index underscore q underscore golden. So this info underscore sw is sent to the index underscore q underscore golden function to tell like how the reward and the selection of each arm needs to be updated. So over here you can see after getting the info, so based on the info we are updating the arms. Like for over here the cases can be like either it will be case 1 or case 2 or case 3. So based on the info that we are sending, so the arms will get updated. Like either the rewards of the arm will get updated or only the times it has been selected it will get updated. Okay, so and then after this updation we are calculating the q values of each of the arms, and then we are comparing the q values and finding out the maximum q value. So after finding out the maximum q value of the arm, we are passing the index again to the main function, and over here, and then we are again playing the arm. Like we are generating the reward received for the arm, and then we are checking like if it is lesser than the mean reward of the arm, then again we are generating the info that will be again sent to the index underscore q function. So here we are creating a copy of the arm reward and the arm select for the printing purpose. So this is the way I have implemented the algorithm. And over here you can see like initially each of the arm reward has been taken as 0, and the number of times it has been selected is kept as 1 for the q value calculation. And you can see like I am running the code, that I am running the algorithm like from the second run to the last run. And for the first run you can see, you can sense that in the first case the q values of each of the arms will be the same, because the reward of each of the arms are same and the times it has been selected will be the same. So the index underscore q function will give the first arm uh, having the maximum q value. So accordingly we have updated the its reward as well as its the time it has been selected. So before and in the first run we are by default increasing the arm reward for the first arm as well as the times it has been selected by 1 for the first term. And then we are running the algorithm like from the second run to the last run. So in this way I have implemented. You can implement the way you want. So this is all about the code. Okay, so let's run it on the quick emulator. So as you can see from the probability distribution, you can see like for each of the arms, you can see like the arm 6 has having the maximum probability 0.9. So the UCB algorithm should select maximum number of times the arm 6, and the rewards generated will be the maximum for arm 6. So let's see. Let us run it. Run as launch on quick emulator. Start emulator and run. And also one thing I missed out, that the number of tests I am performing for 10,000. You can perform it for any number of times. So more the number of times, the more accurate the results you can get. Let's give it a moment for to launch it. It has launched, yes, and let's wait for the output. Yep, as you can see over here that ARM6 is having the maximum probability at 0.9, and you can see that the ARM6 has been selected maximum number of times, that is 9233, and also the reward generated is maximum 8314. And after that, you can see that ARM3 has 0.8, so it has been selected 346 times. It is the next uh, second highest reward is ARM3, and you can also see that the number of times it has been selected is the second highest, that is 439. So in this way, you can check it. So our implementation is correct. Also, I have designed like another probability. So in this, you can see I have another main function over here, in which I have changed the probabilities. Now you can see that ARM3 is having the maximum probability like 0.9, and ARM6 is having 0.8. So after execution of this algorithm, ARM3 will have the maximum number of times it should get selected, and also the highest number of reward. So let's run it and check. Run as launch an emulator. And rest of the code remains the same. Let's wait for the emulator to launch. Let's see. Yeah, now you can see that the ARM3 is having the highest reward 8250, and the number of times it has been selected is also the highest for the ARM3. Second highest is ARM6 because it is 0.8, so it has been selected 428 times, and also the reward is the second highest, like 337. So in this way, you can check the functionality, that whether it is correct or not. So on the quick emulator, we have verified our functionality of the UCB algorithm, and it is working completely fine. Now let us run the algorithm on the hardware. So, I have already created a project like underscore hardware, in which I have implemented the part on the PS and on the PL. So I will just run it like on the hardware by remotely accessing it, and I will check the results. Okay, so let's launch the remote desktop connection. So beforehand, I have already like transferred those files like from my local desktop over to this remote desktop via mail. So as you can see, like via mail, I have transferred these files to users, Mounodeep and SD underscore card. So inside this folder, I have transferred these files. So now we should be good to ready to run. So before running, first open the Teradata, click on serial, click on COM4, click on OK, click on setup, and in the serial port, just change the baud rate to 115200. Click on OK. Now press enter. You can see that you are getting the terminal. Now if you do if config, you can see that no IP has been set for the board. So we need to set the IP for the board. So for that, I've already done this before. Again, I'm showing it to you. Like it will be if config ETA0 192.168.0.10. You can give any other IP. I generally use this. So again, let me check by using if config command. Yeah, you can see over here that the IP has been set. So now we can transfer the files like from the remote desktop to the board by using PSCP command. So for that, open the CMD, get inside the SD card, CD SD underscore card. Inside this folder, I have kept my files and use the PSCP command to transfer the files. So just type in PSCP minus P, capital P, 22, and then the file names boot.bin, readme.txt, sorry, image.ub, and the file name is UCB underscore 8 underscore hardware.elf. So UCB underscore 8 underscore hardware.elf, and then the username and IP address of the board. So username is root at the rate IP address that we have set 192.168.0.10:/MNT. Like we need to transfer the files inside this MNT folder. So we have did :/MNT. And if you press enter, will ask for authentication. Just press Y, press enter. The password is root. So you can see that the files are getting transferred. Yeah, so the files have successfully got transferred like inside the SD card of the board. So now in the Terraterm, press enter. Just get inside the MNT. Okay, we are already inside the MNT folder. So just type ls. So you can see over here like the files are already present over here. So now we need to reboot the board. So go back and then press and then type reboot. So it will reboot the board. Let's give some time for the board to reboot. Okay, so it has successfully rebooted. Let's get inside the MNT folder. So /MNT. So type ls. So you can see over here that the files are present. So to run it, /, the ELF file name, UCB underscore 8 underscore hardware.elf. Yeah, so you can see that the probability, it was defined like for the first case. So my ARM6 is having the maximum reward, okay, 8057, and also it is the maximum number of times it has been selected. The second highest was ARM3. So you can see that the second highest reward is ARM3, and also it is the second highest number of times it has been selected. The number of CPU cycles in software I'm getting as 2843, and number of CPU cycles in hardware is 2043, and I'm getting a speed up of 1.39. So this CPU cycles in software and hardware changes slightly, like varies slightly. Sometimes I'm getting like 1.45, 1.48, 1.39. So it will vary. And also these values, like number of times the arms will get selected will vary, but the trend will be the same. Like ARM6 will always have the highest reward and the highest number of times it has been selected. So these values may change, but the trend will remain the same based on these probabilities. Okay, so you can see that ARM6 is having probability of 0.9. So maximum reward is of the ARM6, and it is maximum number of times it has been selected. So our UCB code is working completely well. So like this way you can test it on the board. So I have tested on the board. So I guess remote access is working fine for all of you. Okay, so best of luck for the homework. Have a nice day. Bye.